So hey guys, welcome back. So in this lesson we're going to talk about the basic measurements in Six Sigma, right? Six Sigma revolves around the notation of central tendency and standard deviation, right? When you think of central tendency, we saw in our normal distribution that the average or the data tends to cluster around the mean, right? So when we talk about central tendency, this is where we use average, right? And I guess an example for average would just be the average is going to be just the x summed all together. So if you have three variables, x1 plus x2 plus x3 divided by n. This little n represents sample size. So when we discuss sample size, we're only looking at a small parameter, right? If it was n, that would represent the population. So the population is going to be that bigger perspective of everything entirely, all your data sets. So let's look at an example with average real fast. Let's say I have four numbers, 5, 3, 4, 3, 4, 8, 3, right? So I want to find what the average of it is. Now, we know this as mu, right? Mu is going to be written that way, or it's a U with a teardrop, right? This designates the average of the data set. Well, based off of our example, x1 plus x2 plus x3, there's your formula for it. So if we said 5 plus 3, that's 8, plus 4, that's 12, and then we had 12 plus 3, that's 15. Well, what's my n in this situation? Well, your n's going to represent whatever the number in your data set is. How many of those do you have? So we know that as 4. So when we set this up, we can calculate what our average is by taking 15 and dividing it by 4. When we do that, we get 3.75 as the average. Let's do another number set to get the average, okay? So let's say I'm dealing with a population of delivery times, right? I've got my first driver, he does 15 minutes. The second driver, 30 minutes. Third driver, 27 minutes. Fourth driver, 16 minutes. And the fifth driver, we're just going to put him at 12 minutes. So what's the first thing we have to do? Well, we have to say 15 plus 30 plus 27 plus 16 plus 12. And I'll add that up for us here. We've got 15 plus 30 plus 27 plus 16 plus 12. How about that? This equals 100. Well, now what's my n? So my lowercase n is going to be 1, 2, 3, 4, 5. So our average time is 20 minutes. So this isn't that hard. This is just basic math right here. Well, let's say I wanted to calculate what the median is. So the median is going to be, let's see, 3. So the way you would do the median is, I just wrote numbers on there, but typically what would you do is put it in chronological order from smallest to largest. Now what median does is it divides the data similarly to like a highway, right? You find what that central number is, right? 1, 2, 3, 4, 5, 6, 7. Well, my median number is 5. So the median in this example is 5. So that's how you do median. Well, let's change it up and say, okay, how do we do mode? Well, mode, most frequent in your data set, right? Well, in this same situation, the most frequent number is 5. So that would be your mode. Now, as I said before in the past, that in a normal distribution, which you need 30 data points, and why do we need 30 data points? Well, it helps us get a better understanding of the population. But the mean, median, and mode are all the same number in a normal distribution. Now, that you have this information to go off of, in Six Sigma, we have central tendency, right? That's also determined by your sigma value, right? So what sigma does is it allows you to understand the space in between, right? And as I had on my example, I had Dave Matthews there, but the space in between, and that's what sigma is. Now the sigma formula, let me do a better job of writing this for you guys. Right, and I have the sigma values here, right? Well, just like I said, sigma lets us know how far we are away from the average. So in this, as we're looking at this, I want to give you the formula for sigma. Essentially, sigma is the square root of E, which is sum, xi, which is your observation value, mu, or x bar, same thing, mu and x bar are the same thing, squared divided by n minus 1. Now, as I said in the earlier video, n minus 1 gives us that degree of flexibility in our calculations, right? Normally, it gives us a confidence interval of at least 95%. Now, it depends on the variables you're working with, but in a normal industry, you should have a confidence level of at least 95% to make a scientific study. Well, if you take 5% from the 100, that's left over, that's going to be your margin of error. And so this n minus 1 is essentially wiggle room in our calculations. So let's look at this example real fast, right? We're going to use this formula still, right? But I have these numbers 9, 4, 3, and 6, right? Well, the easiest way to solve this is to start with your variables, right? What's your x bar? What's your n? And so this allows us to get that, right? Well, to get your x bar, that's your average. Remember we said the average was adding all your values up and dividing by that lowercase n. So 9 plus 4 is 13, 16, 22, all together, 22. 9 plus 4 is 13, plus 3 is 16, plus 6 is 22. And then I have n minus 1. Well, I know, let me back up. So I have 22, n minus 1. So n is going to be what? Well, n is going to be 22 divided by 4. Now, when I do this, I'll get a x bar value of 5.5. And I have an n of 4. Okay, so what does that tell us? Well, in order to solve this, you guys remember back in grade school, PEMDAS, right? Parentheses, exponents, multiplication, division, addition, subtraction, right? The PEMDAS method is how we're going to be able to solve this, and it's also called order of operations. In your order of operations, you start with your parenthesis first. So if you guys will start with the parentheses, our xi, that's going to be our observed value. Well, we have 9 here, 9 minus x bar. Well, I know x bar is 5.5. And then I'm going to go ahead and just add the square. We're not doing it right away. We're going to go down and work on our parentheses. So in this, right, I've got 9 minus 5.5. 9 minus 5.5. That's going to equal 3.5. And then don't forget we have to square it. We're going to work through the equation and then we'll do it. 4 minus 5.5. That's a negative 1.5. 3 minus 5.5. Well, I know that's going to be a negative 2.5. And 6 minus 5.5. Well, I know that's going to be 0.5. So I'll add squares to these, right? Because we're essentially what we've done is we've eliminated this part of the equation. Okay? And we haven't added them up yet, but now we go from parentheses and we go to exponents. Well, let's just do this. 3.5 times 3.5, and I'm just going to move this down here, 12.25 1.5 squared, that's going to be 2.25. Negative 2.5 squared is going to be 6.25. And 0.5 squared is going to be 0.25. Well, I've already gone through and I've eliminated the exponents there, right? So now I have to look at here, and what do I have left? Well, I've already eliminated that. So now I want to eliminate this whole area. Well, this represents the sum of the equation. So essentially, E means adding all of your values that you got. So I'll add 12.25 plus 2.25 plus 6.25 plus 0.25. And I get 21. So essentially, I've eliminated this whole situation, and I'm just going to erase this because you guys already have this. Now I'm left with 21 over, we know n represents 4, 4 minus 1. So if I take 21 and I divide it by 3, because if I say 4 minus 1, that's going to equal 21 over 3, which I divide that, I get the square root of 7. And then if you have a phone, all you've got to do is turn it over this way and then square it. And you should get 2.6457 remainder decimal, right? Now, in this, what this is saying is as you line up these values, right, we have our little bar curve right here, 5.5. That standard deviation is the space between this data set from the average. So in this is how you calculate standard deviation. In the next video, I'm going to show you how to do this using Microsoft Excel to save you a hell of a lot of time.